So, hello and welcome everyone to the sixth and last session of this series about the 12 factor apps. I hope you've enjoyed it so far. I know I did. Today we will be discussing the final two factors of the 12 factors. This is going to sum up like the list of all the 12 factors that the factors suggested by the 12 factor methodology, and hopefully you found this useful and you actually start using this in your daily work. So let me jump right into it. Today's session is not going to be that long. I thought I might just keep it short and quick for you guys to sum it all up. The first factor we'll be discussing today is logs, and I guess you might have come across this term before, log. So it's basically like just a bunch of events, or as they call it here, like a stream of events that describe stuff happening in your app. And logs are useful in so many ways. They can help you figure out a problem that's going on in your code or in your app. They can help you just keep track of whatever is going on. Maybe, as we will see in the demo in a couple of seconds, run some metrics, get a hint or an idea about like some trends going on your app. Let me first start, as I always do, by defining some vocabulary, and first of which is what is a log. Well, what are logs? So as I said, there are streams of aggregated, which means collected, because your app might have multiple processes running. So this is just an aggregation of all of these logs in just one place. They are time-ordered events. So whenever something happens, it just gets printed out at the time it happens. And as I mentioned, they're collected from all of your running processes, as well as the backing services as well. Usually logs come in raw form, and they're typically text with one event happening per line. So it's as if you're opening up a big text file, and then with each line you read from that file. It gives you an idea about a certain or specific event that happened in your app. And as I mentioned, logs are a stream, which means that they do not have a fixed beginning or an end. They just flow continuously as long as your app is running. And the 12-factor app should never concern itself with what happens with its logs. And we mentioned this once before, like in a previous factor, where your app shouldn't be concerned about its environment. There are other process managers or whatever that are responsible for dealing with this. All what the app cares about is just outputting these logs. And as we mentioned before, usually the standard output is the place where these logs are usually dumped or displayed. So your app shouldn't manage the log files where they're written, or if they're like recycled in case their size gets too big, or anything that has to deal with the logs, except the fact of just outputting them or creating them. So the event stream of the logs shouldn't be buffered. And what I mean by buffered is that the app shouldn't just keep on accumulating logs together and just dump them as a bunch. They should be outputted as soon as they happen, right, to standard output, as I mentioned before. And usually, while we're working with our apps during development, the terminal is the place where all the logs are shown or displayed. You just see them in front of you, like in this black screen. And this is okay because it's expected by the developer to see these logs during development to help actually develop the app. And but like in the staging or production environments, this differs because these logs are captured by the execution environment, as I mentioned. They are put together. They might be routed to some other place for archival or filtering or analysis or or actually depending on what you might need these logs for. So yeah, you can just index them for analysis. You can just dump them for the purpose of going through them later in case something goes wrong and then you need to do some debugging. And usually this is great to keep track of the logs that happen from your apps, just in case you want to as I mentioned, follow up on a certain trend, maybe graph some metrics that have to do with your app, or even like implement active alerting where you get a notification or an email, for example, in case something wrong happens. And to show you how this works, let's jump right into the demo. So as I mentioned before, I have everything with regards to the slides and the code that I write during the sessions in a GitHub repo under my username Ramino. So you can just head towards head to github.com/ramino/12factorapps, and you'll see the code from all of the previous sessions as well as this session. You can also check out the slides in the link over here. I hope I'm pointing in the right direction. It's the bit.ly/ramino-12factor link. And you can follow along with me if you have Go installed, because I won't be using any external tools today to like do the demo. All I'll be doing is just writing a bunch of code to demonstrate how logs work and also how we can make use of these logs to implement active alerting, for example. So let me start off here with this empty directory. I'll be creating two apps here. One is our actual app, which I'll just call app. And inside of this, I'll just have one main.go file. And this will basically, this file will basically serve the purpose of like a web app, which is receiving and handling requests and just printing out the result of these requests. And as I mentioned, I'll be just simulating the web app, not actually implementing any actual logic in it. So I'll be dealing with the part where the logging happens. And as I mentioned in the slides, logging in our case, or in the 12-factor apps case, is just printing out to standard output. And we have done that before. So let me do that real quick. I want the app to print different status codes, like HTTP status codes, which will be simulating requests coming into the app and responses to these requests. So I'll create a quick slice of statuses here, which are just like a slice of ints. Let's say I'll have the status OK, which is 200. I'll have the status not found, which is the 404, and the status internal server error, which is the 500. And if I hover over these, you can see, like, I prefer save. So if I hover over these, you'll see that, yeah, that's the 200, that's the 404, and that's the 500. So these are like an examples of the different status codes that we might get when running a web app. And what I'll be doing next is that I'll be just picking a random status from these. So I need to have some sort of a status, like a random status index. And that would be just a number between 0, 1, or 2, because I'll be picking one of the statuses inside of this slice here. And to do that, I'll make use of the rand package, and it has like a function inside of it called int n, that given the number of statuses that I have, and I'll be using len of statuses here, it will just give us a number between 0 and 2 inclusive, so 0, 1, or 2. And for this, I'll be using this index to grab one of the statuses by just calling statuses of this random status index. Okay, I don't want for this to happen just once. I want for this to keep on going, because as we mentioned, logs are just a stream of events. So I'll have an infinite loop going in here, picking a random status, printing it out, let's say like this. So we got 500, for example, and I'll pass the random status here. then I'll be sleeping for a second so that we don't have like an overflow of events happening, just to keep track of what's going on. So let me just sleep for 1 second here. Okay, so one other thing I'll be doing is that I won't be just dumping the status number here. Let me also add some description to that status, which is %s, so like a string description of it, and we can make use of a function inside of the HTTP package we're using, which is status text, if I can remember correctly. Yes, and we'll be passing it the random status that we picked. Okay, and if I add it here, it will be included in our log message. Okay, so let me run this quickly and see what this outputs. Okay, so this is the directory where we are right now. Let me just do a go run app. I need to cd into the session 6, then go run app /main.go. And we can see here that it keeps on printing like 500, internet server error, 200, okay, 500, 500, 404 not found, and so on and so forth. So we get this status code and then the status text over here, which is a description of the code we just printed out. Okay, so that's the first bit of the demo here. We have our app running, it's producing a stream of logs or a stream of events, with each event using up one line, as we can see over here. So the 12-factor app, which is what I'm simulating over here, does not know what's going to happen with the logs, it just prints them out. But the execution environment, as I mentioned in the slides, is responsible for handling or dealing with these logs. And for this purpose, I'll be creating another app inside of here, which will be called like a monitor. And this monitor will be basically just receiving the logs from our app and doing some stuff on it. Okay, so let me create the main function here. And in order to be able to receive input, so what we have done in the app is that we've been producing stuff out. So we're using the standard output like file descriptor to print stuff out to the terminal. But in case we want to read stuff in, there's like an equivalent to the standard output, which is called the standard input, or std_in, and this can be used to read stuff into the app and not like dump stuff out. And to be able to do that, we can make use of the OS package and just call std_in, and that would be the file descriptor for the standard input. Then we need some way to read it, and for that I'll be using the scanner struct from the buff.io package by just calling like buff.io.newScanner, and this will create this sc object, which is a scanner object that can read one line at a time from this input stream. And we need this to go on forever, so I'll have a for loop here that goes as long as the scanner can scan. So scan here is a Boolean function that returns true if the stream is still open and we're able to read from it. And to actually read the line from the stream, we can say sc.text, and this will be just reading one line at a time from the stream we have here. To make sure that this is actually working as expected, let me print it out. So let me say fmt.printf this line, and to make sure that we're not just seeing the logs from the actual app, but rather what's being read by the monitor, I'll add like a prefix here. Let me just say log %s, so that it says log, then the actual log message that we got from the app. If I save and then try to run this, so go run monitor main, nothing will happen because this is waiting for some input to come into the monitor for it to log it. Okay, so what we'll be doing here is we will be first running the app like that, and we'll make use of the pipe operator, this bar operator, which is basically a way to pipe or pass the output of one app, which is on its left side, into the input of whatever app we run on its right side. So if we type go run monitor on the right side here, whatever output is being produced by the app on the left is going to be passed or piped into the monitor on the right. And if I hit enter now, we can see that now it prints log and then the log message that we get from the app. And there's something I need to fix here because it's printing everything on one line. I just need to add a new line at the end here. And if we try to run this again, we can see that it prints out the log messages that it receives from the app, and it is the one doing that because we can see the log colon appended to the beginning here. So this is basically how logs are handled. So this app has no idea who's listening to its logs. It just dumped them in an unbuffered manner to standard output, and then these logs are piped or redirected to the monitor's standard input stream, and in here we start reading the stream and simply just printing it out for now. Okay, so that's like the basic example of how we can make use or how we can route our logs from our app to some other place where we can do like just archival in this case, or just printing out. So one other thing that is app running, we need to get notified in case a lot of 500s are happening, because mostly when a 500 occurs, this indicates that there's a problem with our app. So we need some way to get notified whenever, like, for example, 5 consecutive requests are responded to with a 500. So to do that, we cannot just use the log text we got or this line variable, which is the log text that we got from our app. We need to first extract the status from it. Okay, and let me run it again to show you how it looks like. So we can see that we have some text. We got then the actual status code, and then some like description of this error that happened. So in order to be able to extract that, I'll just use some string like manipulation stuff, or maybe use regex, regular expressions. For those of you who don't know what regular expressions are, it is just like a fancy way to deal with strings in case we want to extract stuff from a string, or just I don't know, maybe validate that a string has a certain structure. We can just like split the string up between like into like words using the spaces here, and just grab like the 4th word that occurs in the string, parse it into an int, and then we will get the status. But let me try to play around with this regular expression stuff. So we need to create a regular expression, and there is a way you can learn about regular expressions. Let me try to remember. Like there used to be a website that actually helped me learn a lot about regular expressions, which is called regexper, I guess. Let me check it out. I really cannot remember where the website was. .fr, something like that. I hate it when I forget like useful tools like this, like regexper tester, for example. I'm sure it's not that first one here. There used to be one that actually describes. So this one can be used to test out a regular expression that you already have, but it doesn't actually. Or is it that one? Because actually it is that one. Yeah. So if we make this a little bit bigger, I guess it will be. Yeah. This is what I was looking for. So basically on the right here, you can see that it has like a quick reference for the different styles of regular expression that we can have. So for example, if I have a string, let me copy over that string and work on it on this website here, just to give you a hint on how regular expressions work. Okay, so I need to paste it here. This is a test string. So we need to extract this 500 from here, and this 500 is just like a digit. And to deal with digits in regular expressions, we use this syntax that is \d. And \d, if we hover on it, we will see that a \d matches a digit, which is equal to a digit between 0 and 9. So that captures just one digit. and we can see like on the right here with the match information section that it was able to capture 3 different digits, but we don't want them to be separate like that. We need them to be together, and to do that we can either use the plus sign here, which says 1 or more digits. So if you hover here, we'll see that it says matches between 1 and unlimited times, as many times as possible, giving back as needed. Okay, or we can be more explicit about it and say that we need 3 digits using this syntax here. So this says that it matches exactly 3 digits. Okay, so it matches 3 3 times of whatever precedes it, and in this case digits. So here we're just saying we need to capture 3 digits. Okay, so this is what I'll be using here, and let me copy that over and then push this back to the right to give us some space to code, and put it over here. So I want to compile this, and to be able to use backslashes in a string we need to add an extra backslash here, so that we can escape this second backslash. So now I tell it that I need to look for digits that are 3 digits long, or numbers that are 3 digits long. Then if I hit dot, let me first save. If I hit dot, we will see find string, and then we give it the string that we want to test, which is the line, and this should return to us whatever match it finds as a string. So this should return to us this 500 here, and to test it, let's put it in a variable. So status string is equal to that, and let's just print it. Okay, print f got as status of %s status string. Okay, let me save and then run again our app with the monitor, and this should start saying that yeah, we got, and again I forgot the backslash n at the end, but we can see here that it says got status, and it prints out just the number out of the log message that we got from the app. Okay, so let's parse this into a string, an int first. So let me do that using the string conv package. We have this atoi function, which is short for ASCII or string to I integer. I give it the status string, and then if error is not nil, which means that something went wrong with the conversion, which won't happen because we're being explicit here about what we're looking for, a 3-digit number. But just in case something wrong happens, let me just print fatal f failed to parse status, and pass the status string here and the error that happened. If not, we'll be having the status here, and to confirm I'll switch this s to a d because we're now printing an int, not a string, and I'll print the status variable that we created over here. Okay, let me save, try to run that again, and it works as expected. Cool, so now we are just capturing the status code that we got from the logs. Cool. So far we haven't done any active monitoring, and to do that we can actually start counting the number of 500s that we get. So let me initialize a variable here that I can call var num of 500s, and that is initialized to a 0 because I'm just defining it here, and it defaults to the default value of int, which is 0. And whenever we get a 500, so let me get rid of this print statement here. Whenever we get a status that is equal to 500, internal server error. I'm just using the constant to make it more readable, but this constant is just, as I mentioned before, a shortcut to the number 500, the status code of internal server error. So if we get this, let's increment the number of 500s and then check if the number of 500s is a factor of 5, because we only want to print this whenever, like every fifth time whenever we get a 500. So if we check that this modulus 5 equals 0, which means that this is a factor of 5, we are going to fmt.print len which will indicate that something wrong has happened. Okay, this can be replaced with a call to like sending an email or something. Okay, so let me save this. Give us some more space here to be able to run the code and see the whole output and run our program again. So we start by getting a 500. That's 1, that's 2, that's 3, that's 4, and on the fifth one we should get the error message here. The fifth one, it says oops, and that is exactly what we are trying to do. And then it resets again because it starts again counting 5 more 500s, as we can see here. So 1, 2, 3, 4, and after the fifth one we get the oops message again, which is exactly what we intended for this to do. Okay, so now we have a very basic form of active monitoring or active alerting for our app. We can get notified whenever something wrong happens, and this is one of the uses of redirecting logs from our app to like some sort of an analysis service or a monitor like what we have in this case. Cool. So this sums up this factor, and now we're at the last but not least factor of the 12-factor app, which is admin processes. And actually this factor might be considered by many of us as a factor that doesn't really count, but it's actually a very important one. And to understand the importance of this factor, let me first define what I mean by an admin process. So basically, an admin process is just a one-off task that runs for the app, such as, for example, migrating the database, modifying some data using like a REPL shell, and by REPL I mean the read, evaluate, print loop, which is basically a way that is provided by some programming languages where it gives you a terminal that has your app code loaded, and then you are able to input some commands, execute them, and then maybe modify the state of your app like in runtime instead of having to do it in the code. And it can also be like admin process can also include like one-time scripts that you can run, for example, cleanup tasks or jobs that you need to run just one time or a couple of times alongside your app's code. And admin processes should always run in an identical environment as the long-running process of the app. And what it means by that is that if we have a web app running in a certain like production environment, admin processes should also run in the same identical environment, just to avoid any clashes that might happen because of like discrepancies in the code versions that are being run, or like the database version that is being used or something like that. So we always run admin processes against a release, which means a freezed version of the code base alongside a certain version of the configurations, just to make sure that the process is running in the same environment as our app. And this ensures that nothing wrongs happen because this avoids conflicts and any kind of synchronization issues. Cool. And it also ensures that, like, if we have some dependencies declared and we're using some sort of a dependency isolation tool, that the admin processes run in the exact same, run with the exact same dependency versions as the app, also to avoid any conflicts that might happen. Cool. And 12-factor apps strongly favor languages that have a REPL, as I mentioned, which is, again, just a shell that we can use to inject or execute some one-off scripts. And usually, like in local development, this happens by using the terminal. So we just open up a terminal on our machine and execute some code in it, which runs against our app. But in production, usually this is done in one of two ways. Either we remotely access the REPL of our apps running in production, which is a not very advised way, in my opinion, to do stuff. But it can be done, for example, in case of emergencies where you need to run a certain command to fix a bug, like a logical bug or something. But it's always advised to instead deploy a new release of your app that has this one-off script included there. So usually what happens is that an extra directory is added to your app that has the one-off script that you want to run. You you go through the deployment process so that this version of that script gets deployed alongside your app in the like final, for example, production environment, and then you just use the SSH or the remote shell to execute the script without having to write your code yourself. And this gives you time to test this script thoroughly during development. Make sure that nothing wrong, no side effects happen whenever you run it, and it's also kept like in your repos code history, which means that in case you need to refer to it again in the future, you will find a version of it to use instead of having to go through its logic again. So this summarizes what I have to say about admin processes, and as I mentioned, this is a short session, but this brings us to our last slide here. I would like to thank all of you for keeping up with me during the 6 sessions. I hope they were not too long or too short. I hope that I was able to convey to you the importance of like following the 12 factors and implementing them in your apps. And I hope that I was able to show you how useful they are to make your lives a whole lot easier and more comfortable when it comes to debugging your app and fixing it and making sure that it's error resilient. So thank you for watching. This was Rami Abul Naga. You can always contact me or reach out to me using my username or handle here. It's almost the same on all of the social networks. Just click on this and you will be redirected to my personal website where you have links to all of the communication method that you can use to reach out to me. Again, thank you very much. Stay safe and see you in another course. Thank you very much. Goodbye.